Today in lesson 4.1, starting our trig chapter. Okay, so we're going to take, some of us take a little bit different thinking. Today, though, is more just some conversions, some basic information here. So, a couple of definitions here. Degree. You guys are familiar with degrees, right? A degree, represented by the little bubble symbol, right, is a unit of angular measure equal to 1/180th of a straight angle. Now, officially, that's them defining what a degree is. But you guys know, a straight angle, a straight line, how many angles on a straight line? That is 180, yes? So they're saying that a degree is 1/180th of a straight angle. Okay, we could say it's 1/360th of a circle. We could say it's 1/90th of a right angle. Okay. Now, first thing we're going to talk about here is DMS, degree minute second, which is a system of measurement. I feel like you see this more with like latitude and longitude, so you've probably seen it in your social studies books a little bit. But in degree minute second, system of angular measurement, each degree is divided into 60 minutes, denoted by a little singular like apostrophe. And each minute is divided into 60 seconds, which is divided by the double, so more like a quotation mark. Okay, you've seen the minute and second marks. If you're like me, you may get confused about which is which, but
like feet and then inches.
Do we use them with feet and inches also? Yeah. That's what I'm trying to think.
Yeah, feet is 1 and then inches is 2.
Yeah,
like
same idea.
Height, they did the one
Yeah, there you go. Except here we're talking minutes and seconds. Now, okay, so we're going to start with, and we're going to go both ways here, but this first one is how do we convert degrees, 37.425 degrees, to DMS? So how do we break it into degrees, minutes, and seconds? Now, what do we know already? Start with the obvious. How many degrees are there going to be?
37.45.
We're breaking this into degrees, minutes, seconds. How many degrees are there?
37.
Okay, so we know that there are a whole 37 degrees, yes? Now, that means the 0.425 degrees represents the minutes and seconds. So what we're going to do is we're going to take that 0.425 degrees that is left, and the relationship we know is that what do I want to say here? Each degree, right up here, each degree is divided into 60 minutes. So 1 degree is 60 minutes. If I have 0.425 degrees, how do I change that to minutes? Multiply by 60. Now, I'm going to have you thinking of dimensional analysis, where you guys use fractions to convert between measurements, right? We're going to do some of that today. So the idea that if I'm going from degrees, 0.425 degrees, I want degrees to cancel, so I put degrees on the bottom to get to cancel, right?
So it's like a ratio.
So, yeah, you can think of it like a ratio, or as we use it when we do our conversions. Because now the degrees can cancel. And 0.425 times 60 is what?
25.
Okay, this is 25.5. And at this point, this is 25.5 what? Minutes. So, what do I know towards my answer right now?
25.
Okay, but we're trying to go to minutes and seconds, so this is
25 minutes.
25 minutes. So far we know 37 degrees, 25 minutes. Now, you can probably use some logic here and figure out the seconds, but I want to talk mathematically. How do we do it when it's not an obvious 0.5? We're going to take 0.5 minutes, right? So same thing like I did earlier, and we're going to convert it. What's the relationship between minutes and seconds?
60.
60 seconds in a minute, right? So what are we going to do here? 60 seconds in 1 minute. Because I want my minutes to cancel, we're multiplying by 60 seconds. And what is 0.5 times 60?
30.
I know that's a shocker, right? And that's going to be 30 what?
Seconds.
30 seconds. Whoops, not what I wanted to do there. I want to cancel those. Okay, and that 30 seconds is the rest of our answer. So 37 and 425 thousandths degrees is equivalent to 37 degrees, 25 minutes, and 30 seconds.
So what would you use this for? Like, in real?
I feel like latitude and longitude is where I see it most, like measuring distance. In terms of, degrees are pretty far apart, like Sharpsville, Indiana is at some certain degree.
Yeah.
But if we're going to get specific, degrees going to cover a decent sized distance. And so breaking it down, and I break it down into hours and minutes and seconds.
So they
after that.
got
Next
like 50
time
places.
someone asks for my
Huh?
It'd be like minutes, seconds, and like 50 places based
Uh-huh.
on the Okay, that makes
Yeah.
sense. That's kind of cool.
That's
Like it's
Okay, guys, let's try the next one. 157 and 892 thousandths degrees. And we want to change this to DMS again. So what do you know off the bat, right off the bat?
157.
Okay. I know it's going to be 157 degrees. And then I'm going to take my entire decimal. And what am I going to do with this 0.892 degrees?
Times it by 60.
We're going to times it by 60 because there are 60 minutes in 1 degree. And what is 0.892 times 60?
53.52.
53.52. And officially that is 53.52 minutes.
Minutes.
So what do we know right now of our answer? 53 minutes, yes? So you see how I'm doing this. I'm grabbing the whole number and taking the whole number. So I know we're at 157 degrees, 53 minutes, and this is why I worked the last one out. Do you know what 0.52 minutes is in seconds off the top of your head? No. So this is why I showed the process last time, okay? So take the 0.52 minutes and do what?
Times it by 60.
Times it by the 60 seconds that are in 1 minute. What is 0.52 times 60?
31.2.
And that is 31.2 what?
Seconds.
Seconds. That's because our minutes canceled. Now, are we going any farther with this?
No.
No. So I'm going to guess, yeah,
Can we go to like milliseconds?
I'm going to pass that.
That was on.
So we're going to stop here. We're going to give the 31.2 as our precise seconds. So 157 degrees, 53 minutes, and 31.2 seconds.
This one's really hard. Pay attention.
Okay. Now, we've got to go the other way. I'm going to give you the amount, 42 degrees, 24 minutes, and 36 seconds. And I want to know what that is as degrees. Now, what do we know right off the bat without doing any work? Yeah. This is going to be 42 point some degrees, right? There's the obvious part. Got it out of the way. Now, we've got to change 24 minutes and 36 seconds to degrees.
Why don't we start
Okay.
from the right? Work our way left.
You could
You take like,
kind of, okay, so,
you take like 0.36 and divide it by 60.
and change that to minutes and then the minutes to degrees.
Yeah.
You could. So there's a couple different ways we could do that if we want to look at it that way. I was going to do it all as one step, actually. Okay, but the idea that you're all hitting on is these last ones we were multiplying, yes? So here we're going to do the opposite. We're going to divide. Now, so no, if we take your option, which is not the direction I was going to go, but I'm not going to rule it out, you're going to take 36 seconds,
Mm-hmm.
change it to minutes, and then you're going to have 24 point something minutes and change it to degrees. Okay? Not against it. My thought, okay, so 24 minutes. What do we know about 24 minutes to go to degrees? Minutes to degrees, you're going to have to divide by 60. Now, what about seconds to degrees?
120.
360.
Right.
Tweak Mario's, not 360.
1 over 1's 360.
No.
270.
Now you're just throwing numbers.
Okay, my point was Mario had it closest because here's the deal. You're dividing by 60 not once, but twice. And 60 times 60 is...
120.
60 times 60 is not 360.
Not
3,600.
3,600.
Oh, I
So Mario was short of zero.
Zero.
That's what I was trying to get at.
I had 120. I was close.
Okay, so here's going to be my suggestion. We're going to have the 42 degrees, yes? And then we're going to have to do the 24 minutes. And we're dividing that by 60. When you take 24 minutes and divide it by 60, that's going to become degrees there. Okay? Plus, we're going to have to take the 36 seconds, and we're not dividing it by 60. We're dividing it by 60 squared, which is 3,600. Now, if you get talented enough, you can put that all in your calculator at once and not have to do more than one calculation. Now, are you guys doing it individually, though, I'm guessing right now?
Nope.
No?
I'm going for it.
You're going for it? Okay.
I got
Oh, just kidding.
42.1.
42.1. Oh, yeah.
Because it came out as a fraction. Isn't there some way to switch it from fractions?
Yeah, if you go into your math menu, there's a fraction to decimal option, or decimal fraction, so you can use it either way.
She would have us like switch it all the time. I can't
Yeah.
remember
Okay. Do we have a final answer yet?
how. Yes.
What are we thinking?
42, 42.1.
Final answer is 42.41 degrees. I agree. And here's the deal. 24 divided by 60 is 0.4. 36 divided by 3,600 is 0.01.
Oh, I multiplied.
Okay? Now, did you figure out how to do it on your calculator all at once?
Yes.
I mean, if I do 42 plus, I can do a fraction. Whoops.
Takes long.
24 over 60 plus a fraction of 36 over 3,600. Now, okay, I think the, no, I do not on this calculator. It's an over calculator. Okay, guys, now, I get a fraction answer. This is where Connor was discussing, you know, this is obviously not the answer I want. If you go into your math menu, the top one is fraction, the second one is decimal. I want to take this to a decimal, and so I can do that right there.
Oh.
Okay, so you do have that option, just like you did on a scientific calculator. Okay, questions?
Nope.
Have you tried the next one?
Just did it.
Now, and I will say on that last one, you could have done them by piece, right? 42 plus 0.4 plus 0.01, and you would have gotten there just fine. So let's see, 125 degrees, 56 minutes, 35 seconds. Well, in my brilliance, I know my answer is 125 point something degrees. Okay? So I know there's going to be 125. 56 minutes, how am I changing that to degrees?
56 over 60.
Dividing by 60, that's going to be degrees. 35 seconds. How am I changing that to degrees?
3,600.
Yeah, you're dividing by 60 twice, which is 3,600. I have my answer with 3 decimal places.
That's good.
Okay. Now, I will say if you do 56 divided by 60 by itself, you get 0.93 repeating, I believe.
Yeah.
If you do 35 divided by 3,600 by itself, 0.00972,
Repeating.
and the 2's repeating. Those would be, you'd want to, if you're adding these by hand, if you're adding these, you're going to want to go up to your calculator and grab them to add them, aren't you? Okay. But if we just put it all in at once, it works out pretty nicely. You end up with 125.943 degrees. Are we good with that?
Yes.
So I don't need to show it on my calculator?
Nope, no.
Okay. I will go for that then. Okay. Good stuff to know, right? I'll be honest, we don't use this a lot in this, it's not like we use this much in this chapter, but it does pop up on occasion, and it's good stuff to know.
Trigonometry?
Trigonometry.
Okay, on the bottom half here, we are going to work with converting between degrees and radians.
This would have been
Okay, this, what'd you talk about?
We were talking about radians the other day in physics.
In physics?
I did not know what a radian was.
Okay, so guess what?
Radian.
This is where we are headed. So, okay, when working with trig functions, we'll be using radian measures of angles. Each degree has pi over 180 radians. Okay, so when we look at the unit circle, okay, so the circle hanging on the wall back there. Okay, that unit circle, what do you guys know a circle as?
Round.
360 degrees, yes? Okay, so 360 degrees is an entire circle, or half the circle is 180 degrees, yes?
Yep.
Well, the entire circle is also 2 pi radians. So if you start, 0 is actually at, if I say 3 o'clock, does that make sense?
Yep.
And I don't have it on there, but where it says 2 pi, that is also 0. Okay, I haven't put any new markings on there this year. I erase them every year. Okay, so 0, the beginning and ending point is there at 3 o'clock. Okay, so when we talk radians, an entire circle is 2 pi radians. That also means if a whole circle is 2 pi, half the circle is 1 pi. And so thus, you're looking at pi radians is equivalent to 180 degrees. And so that's where our conversion unit comes from here. Now, if we're trying to go from degrees to radians, then we're going to multiply by pi over 180. And I think of that as pi is my radians, 180 is my degrees. So I'm trying to get to radians, so I'm multiplying by the pi, dividing the degrees. If I'm trying to go from radians to degrees, I'm trying to get rid of radians, so I'm getting rid of the pi, and I'm trying to multiply by degrees. Okay? Now, so those are your factors to be familiar with. And here's the deal. It's not going to be just a flat out plug it in the calculator. Because when we talk radians, we occasionally talk decimals. But usually our radians look more like what you see on the unit circle there, where my radians involve pi in there. So pi over 2, pi over 3, pi over 6, 3 pi over 4. We usually talk in terms of fractions when we talk radians here, and they have a pi in them. So let's practice with some of these. How many radians are in 90 degrees? So how am I going to go from 90 degrees to radians?
Times pi over 180.
Okay, so officially, we're going to take 90 degrees, and since we're trying to get to radians, we're going to multiply by pi over 180. Now, don't think calculator with me, or don't think calculator, think with me here. When you multiply this and make it a fraction, 90 times pi over 180 is going to be 90 pi over 180, does that make sense? Now I'm having you think about that because what do you know about 90 over 180? That's 1/2. And so if I say 1 pi over 2, or in other words,
Pi over 2.
pi over 2. And that is pi over 2 radians. Okay? I don't want a decimal answer there. I don't want 1.57 as your answer there. I want you to be in the habit of we express these answers in pi most of the time. Okay? Now, I saw multiple people looking at the unit circle. Does it make sense?
Yep.
If we already talked about 180 degrees as pi, well, 90 degrees is half of that, right? So it makes sense that 90 degrees is 1/2 pi. Okay. B. How many radians are in 250 degrees? So what am I going to do? (250 degrees times pi over 180. Now, my brain says if I have 250 on top and 180 on bottom, what do I know I can do right off the bat? 250 over 180,
25.
because the zeros can cancel, yes? Okay, when you have numbers ending in zeros, they're multiples of 10. You can cancel equal zeros. So then I end up with 25 pi over 18. Are there any other common factors there I can divide out? No, 25 only divides by 5. 18 doesn't divide by 5. So 25 pi over 18 radians. Now, 18ths is not a common radian we talk about, so that's not one that you're going to be able to look over there and find marked on the board. Okay? But I'm going to leave it like that. Okay, C, you ready to reverse it? How many degrees are in pi over 3 radians? So what are we doing this time? Taking pi over 3 and this time, since we're trying to go to degrees, we're multiplying by 180 over pi. Yeah. Get rid of those pi's, yes? Or that's not even what Hannah was talking about, but
It is.
okay.
Sorry.
No, there's actually 2 ways we can cross cancel here. I just wasn't.
60.
Yeah. So, yeah. My brain automatically says, okay, here's the deal. The pi's cancel. When I have 180 over 3, we know that's going to be 60 what? Degrees. Now, with degrees, I should see a degree bubble as your label. Okay? With radians, I'll be honest, you don't have to label radians. If something's not labeled in measurements, we assume it's radians because degrees should always have a degree bubble on it. Okay? Okay, can you do D then? How many degrees are in 5 pi over 18 radians? So, trying to go to degrees, so we're going to multiply by 180 over pi. What did I do? I did, didn't I? I'm like, something does not look right here. There we go. Am I there yet? Whew, okay. It is. It's a struggle.
The pi's still cancel. Right?
Okay, pi still cancel. I personally also would look here, 18 and 180. Yeah, they both divide by 18, yes. And so when I cancel that, 18 is gone to be 1, and 180 divided by 18 is 10. So then we have
50 degrees.
5 times 10, which is 50 degrees. You figure out how you want to work this, right? Okay. E. Converting 25.5 degrees to radians. Same thing?
Yeah.
We're starting with 25.5 degrees. We're trying to go 2 radians, so which one are we multiplying by here? Pi over 180. Now, at this point, we've got a decimal in there, don't we? So I'm going to go ahead and multiply this. 25.5 times pi is going to be 25.5 pi over 180 for the moment. I say for the moment, though, because we don't traditionally leave decimals within fractions. So how do I get out of a decimal spot?
You multiply by 2.
Well, officially, I was going to say to get out of a decimal spot, we multiply by, what did you say? 10. Okay. Because multiplying by 10 will move my decimal over 1 to the right.
Oh.
So officially, I'm going to say 10. Now, in this specific case,
Because it's.
would multiplying by 2 work?
Yep.
Yes, because it's 0.5, and that would take me to a whole number. Officially, though, I'm going to teach it as, the official rule is 10. 2 is a good shortcut here. Does that make sense to you guys? So if I multiply this by 10, on top, 25.5 becomes 255 pi. 180 becomes 1800. Then can we reduce this?
Yes.
No.
How calculator fluent are you?
Divided by 5.
Because here's the deal, guys. If I type 255 over 1800 in my calculator as a fraction,
That's what I got.
my calculator will simplify it. Now, I didn't put the pi in there because that would have goofed things up. Okay? Because here's the deal. I know pi is going to be my answer.
Yeah.
Okay? I'm trying to simplify the fraction of net width that's with it. And 255 over 180, I don't even know what that divided by at this point, but became 17 pi over 120. Okay? It's a good little calculator trick there. Okay, and one more on this side. Converting 2.5 radians to degrees. How do I convert to degrees? Which one are we multiplying by? 180 over pi. Unusual about this one is
No pi.
there's no pi to cancel. So it kind of depends on the scenario as to how we leave it. If we go ahead and multiply across, 2.5 times 180 is 450.
450.
So this is 450 over pi, and officially this is 450 over pi degrees, which is just not how we usually talk. So in this case, I would probably, since we're trying to go to degrees, I would probably go ahead and divide it out. So what is 450 divided by pi?
143.93.
Where's the pi button?
240.
Oh.
Okay, 143 and 2400 degrees.
Now we gotta convert that to DS.
Oh, I was at 40.
No, we're stopping there. It just asked for degrees.
Thank
Okay,
What are the minutes and seconds?
So-
Noah.
those are basics. Now, as we get into things, I'll be honest, something like, give us a little bit of time to get into this chapter, and I say pi over 3 radians, I'm going to expect you to, that one is one that you have memorized. You know it's 60 degrees. I'm going to expect you to know that pi over 2 is 90 degrees. I'm going to expect you to know that pi over 4 is 45 and pi over 6 is 30. Those are ones we're going to use a lot. Okay? So, good ones to know. Okay. We good here?
Yeah.
Okay. On the back side, we are going to talk about something called an arc length formula. Now, before we do that, a little bit of definition here as we go about this. A central angle is the angle made at the center of the circle. So when we're talking about things like 60 degrees, that is an angle that is going from the middle of the circle, okay, where the vertex of that angle is at the center of the circle. Okay, so that is a central angle there. The arc length, S, is the length of the curved partition of the circle. So, picture time. Okay, right there, I drew a little bit of a circle. I drew a central angle. Okay, that central angle is my angle going from the center. The S is the arc length. And so when I'm talking about S here, I'm talking about that piece right there. So the length of the circle within the central angle. That is what we call the arc length. Okay? Now, with that in mind, arc length formula. Arc length formula is S equals R theta. S stands for arc length. R stands for radius, as it often does. And theta is the angle in radian form. So here where it says central angle, that's going to be theta. The catch with this formula is it only works in radians. So when you talk about that angle, if they give you an angle of 180 degrees, you can't use 180 degrees in that formula. You have to use the radian version.
So is theta a circle with just a line in it?
Yes.
Or a zero? Is a circle line?
Theta it basically looks like, yeah, a circle with a line through it. It's a Greek letter, theta, is what it is.
I knew that part. I was just like,
Yeah, and we'll use theta a lot for angles. A lot. Okay? Okay, so, example here. Find the perimeter of a 60-degree slice of a large 7-inch radius pizza. So the perimeter of a slice of pizza.
It's just pizza.
Okay, now,
I can't, right?
what do I mean perimeter?
All the sides out.
All the sides added up, yes? Now, let's see. There's my pizza. Okay. We're looking for the perimeter of a 60-degree slice of pizza. So if I put my point in the center, there's my 60-degree slice of pizza approximately. Okay? Because that angle is approximately 60 degrees. And what else do we know about this pizza?
It has 7-inch radius.
7-inch radius, and how is that important?
You know that. Just a-
arc length.
Where is 7 inches here? That side of the pizza slice is 7 inches? And?
The other side's 7 inches.
This side is 7 inches. We're being asked to find the perimeter. What are we missing? Yeah, we're missing the arc length. And what is this right here? That's your arc length. That's S. Okay, we don't know that length yet. We have to find it. And we used a formula just now, we were given a formula just now, right?
We did something.
Okay, the formula we were given, S equals R theta. So, we're trying to find arc length. S equals R. What's R?
7.
7.
7. times theta. What's theta?
Pi over
Pi over
Pi over 3.
I don't see pi over 3 in this problem.
But you just know it.
60 degrees.
Okay, so here's the deal, guys. They gave us 60 degrees. However, I'm going to do a side note here. I think you guys already flipped to the front side and looked it up, didn't you? But
I did.
that's fine. That's great. Using your resources. I like it. But to change 60 to, what am I doing? So, well, I could have left that, I guess. To change 60 to radians, we multiply by pi over 180. And so that is 60 pi over 180, or in other words, 1 pi over 3. So that is where the pi over 3 came from, in case anyone was sitting there saying, why is everyone saying pi over 3? Okay. So, S. What is 7 times pi over 3? It's 7 pi over 3. However, do I want to know an arc length that is 7 pi over 3?
First.
No, I'm trying to find a perimeter of a pizza slice here, guys. So, in this case, we'll want to go a little farther. What is 7 pi over 3?
7.3. Sophie.
Oh, I was ready.
7 point what?
3.3.
Okay, so approximately 7.3. Am I done? Yeah, officially they wanted the perimeter. So we're going to take, we already had what? A 7-inch side, a 7-inch side, and now basically your pizza crust is 7.3 inches long on this pizza. So 21.3 inches is my approximate perimeter of a 60 degree slice of pizza from a 7-inch radius pizza.
I'm gonna
That's a small pizza.
and ask them to cut my pizza. I want a large.
I think
Medium topping pizza cut at a
I
45
can eat a 7
degree
pizza
angle.
by myself.
45 degree angle would be easy. That's 8 slices.
Which is what they do.
Do like a 49 degree angle or
Yes.
something.
Okay, now you're being annoying.
Cut at a 43.4 degree angle.
If you did 90, just
Okay, guys.
A perfect 44.
Where are we at time
Cut
wise?
at a 360
Like, one more
degree
minute.
angle. It's a circle.
Okay, guys. I think tomorrow we will start off with this example here because I could start talking about it, but we're not going to get all the way through it. So we'll start off with this example tomorrow.
Is homework due tomorrow?
Homework will not be due tomorrow. Homework will be due on Monday.
Oh, perfect.
Wait, is today Thursday?
Yeah.
Yeah.
Oh,
Oh.
So homework will be due on Monday. So 2 through 42 evens, 45, 50, and 51.